It doesn't like what we're going to do today. But don't let it fool you. All right? You follow the same rules as solving equations, except for the majority of the equation are going to be different letters. Okay? So equations contain more than one variable, and at times we need to solve these equations for one of the other variables. So here it says solve P equals A minus B minus 5C for A. So this is the new letter they want by itself. Treat every other letter as a number. Okay? If I want to get A by itself, I'm going to draw the line through the equal sign. What should I do? How? I would add B to both sides. What does the left side look like now? Equals. Okay. Now what do I do? I wind up with equals. Done. No. No. I wouldn't quite thrown out the word easy there yet. Let's go to the right. A equals 3B plus C, and we're solving for B. Say it again. Minus C from both sides. I end up with A minus C equals 3B. Then I divide by 3. Now here's the deal. Just divide this whole thing by 3. Because A and C are not numbers, you can't reduce. So you can just leave this as A minus C over 3. Now technically, A over 3 minus C over 3 is also correct. But I think this is easier on the eyes. Okay? Solve E equals 2GH for G. Caden?
Would it be 2 divided by G? 9H. Yeah.
Just H? 2H. We want to leave G alone. Whatever you do to one side, you do to the other. 2's and H's cancel, so G is by itself. On the left, careful, E over 2H. R equals 6 times C minus D, and you're solving for C. You can, I wouldn't. As soon as we see that, we're like, ooh, we got to distribute, because then that's how we get rid of those parentheses. And when you distribute, what math operations here? Multiplication. So I could divide by 6, and it would cancel that 6 out front, leaving me just C minus D. Whatever I do to one side, I have to do the other. I just want to show you why you want to divide. So on the left, then I would have R divided by 6. Bless you. Done?
No.
What do I do now? Plus D. Plus D. Question. Is R plus D in the numerator? What's in the numerator? What's in the denominator? Where's plus D then? Very good. Don't mix those two. That's what I wanted to make sure. Don't mix those two. Now, technically, could you distribute 6 in there? Yeah, it gets messy, though. It gets really messy. So if the letter you're trying to get by itself is inside those parentheses, divide by whatever's on the outside so we can just get rid of the parentheses to start with. Okay? Solve 1/8 times x plus y minus z equals w for y. Here's another one of those situations, right? Whatever the letter we want is inside the parentheses. So to get rid of those parentheses, we just said we should divide by 1/8. Hold on. We technically should divide by 1/8. But how do you divide by a fraction?
Multiply by the one.
Multiply by the reciprocal. So in this case, you would multiply by 8 over 1. That cancels the 8s, leaving you just what's left in the parentheses, but you don't need the parentheses anymore. X plus y. Guys, take a deep breath. Some of you are just trying to shout random things, and it is distracting like nobody's business. We multiply by 8 to cancel the 8. It leaves us what's inside the parentheses. But whatever I do to one side, I have to do to the other. So it actually equals 8w. What's my next step? Add z. X plus y equals 8w plus z. Subtract x. Y equals 8w plus z minus x. Question. Right here. X plus y minus z equals 8w. You guys added z. Could I have subtracted x first? You could have. What would have happened is you would have had your numbers in a different order. You still would have had a negative x. You still would have had a positive z. Okay, so with addition and subtraction, it technically wouldn't matter because the signs will still be the same. So the beginning of today makes your brain hurt because you're working with things that are letters that you're used to being numbers, but just treat them like numbers. So props to you guys on that. That's the first half. So the top of this is labeled literal equations and dimensional analysis. We just did literal equations, letters and equations. Now we're going to talk about dimensional analysis. So with formulas and what we were doing with various letters, we have to keep track of units. Remember, units are how you measure something. Meter, miles, feet, inches, different units of measure. Dr. Washington just started an experiment. He will collect data for 8 days. How many hours is this? Now, I know some of you are like, oh, you just multiply this or you just divide this. You have to show this to me because you're going to screw it up at some point today. What do we start with? 8 days. And I'm going to put 8 days over 1. And you're thinking, why are we making a fraction? We need to cancel days. And we're going to change it to hours. Okay? So we need to multiply by something. Currently, days is in the numerator. If I put days in the denominator, they cancel. Agreed? Okay? And we said we were converting days to hours. What is my conversion? How many days and how many hours, or how many hours and how many days? 24 hours in 1 day. So the whole purpose of setting it up like this is to get the unit diagonal from it to get it to cancel. Now we multiply across. 8 times 24 is 192. What's my label that's left? Hours. On the bottom, 1 times 1. What's my label that's left on the bottom? There isn't one. Okay? 192 hours divided by 1 is 192 hours. And I know some of you are going to say, I could have done that just by multiplying by 24. I understand. But guess what? We're going to build on this. Okay? So you start with what you have, what they gave you, and then we have to get it to cancel by putting in the opposite location of the fraction. Flip it over. A gas station is 21 miles away. How far is the gas station in kilometers? Hint, 1 mile is 1.6 kilometers. What do they start us with? 21 miles. I put that over 1. If I want to cancel miles, where does it need to go? In the denominator. What am I converting miles to? Kilometers. What is my connection between miles and kilometers? 1.6 over, how'd you know that? Perfect. I was just making sure you could read. It says that. Miles cancels miles. We multiply across. 21 times 1.6 is 33 kilometers over, 33.6. Maybe I should listen to everything you guys say, huh? 0.6 kilometers over 1. Any label on the bottom? So your final answer? 33.6 kilometers. Okay, so we didn't just go standard to standard, we went standard to metric there. As the Earth revolves around the sun, it travels at a speed of approximately 18 miles per second. Convert this speed to kilometers per second. At this speed, how many kilometers will the Earth travel in 2 seconds? In your computations, assume 1 mile is equal to 1.6 kilometers, and do not round your answers. Here's where we get a tad more intense. What'd they give us to start with? 18 miles per second. So 18 miles over 1 second. Now, what are we trying to convert it to? Kilometers per second. 18 miles per second. So I need to change miles or seconds? Miles. We're going to leave it in seconds, okay? So miles is in the top. To convert miles to cancel, I have to put it in the bottom. And I'm going to convert miles to kilometers. What's my connection? 1.6 kilometers for every 1 mile. Now my miles and my miles cancel. 18 times 1.6 is 28.8, a label of kilometers per 1 second. So the first thing says convert it to kilometers per second. That's what it is per second. How many kilometers will the Earth travel in 2 seconds? How do you figure that out? Times 2. 28.8 times 2 gives me 57.6 kilometers. Now this works. I should write this out with labels why this happens. 28.8 kilometers per 1 second. We took that times 2 seconds, which is really over 1. Seconds cancel seconds, and that's how you know your label. Okay. A car is traveling at 45 meters per second. What's the car's speed in kilometers per hour? Now what's happening? What's different about this problem versus we have to go seconds to hour, but we also have to go meters to kilometers. So now we're changing both things. Okay, we're changing both things. Write down what you have to start with. 45 meters per 1 second. One at a time. You want to go meters or seconds first? Meters. Okay? If I want to cancel meters, where should it go? In the bottom. Meters is getting converted to kilometers. How many are in each? You have to know this metric conversion. King Henry died unexpectedly drinking chocolate milk. I had kids show me this one year. This helps you put things in order. Unexpectedly is like your unit. Okay? So for us, we're trying to connect meters to kilometers. I always start the one furthest to the left, which would be kilometers, right? If I put a 1 under kilometer, then I have to put a 0 under every other letter until I get to meters, which is my unit. So 1 kilometer is 1,000 meters. King Henry died unexpectedly drinking chocolate milk. Kilo, hecto, deca, and this would be like meters, liters, grams, deci, centi, milli. Okay, so 1 kilometer is what? 1,000 meters. So my meters cancel. Multiply across. 45 times 1. 45. What's my label? Kilometers. On the bottom, 1 times 1,000. 1,000. What's my label? Seconds. What did they want our answer in? Kilometers per hour. So we're halfway there, right? Not quite. A third of the way there. Okay. Now I'm going to multiply. I'm going to move this to the next row because I'm going to run into my 1,000 there. Kilometers per 1,000 seconds. Now we need to convert seconds. Seconds currently is in the denominator. I need to move it to the top. Now, seconds does not directly connect to hours. What's the next unit up? Minutes. That's where we need to connect it to. What is my connection between seconds and minutes? 60 seconds in 1 minute. Seconds cancel. And I multiply. 45 times 60 is 2,700. Label. Kilometers. Over 1,000 times 1. 1,000 minutes. Are you done? No. Okay. I need to cancel minutes. Where does it go? In the top. I'm going to take minutes into hours. What's my connection? 60 minutes in 1 hour. Minutes and minutes cancel. 2,700 times 60. 162,000? Yeah. Stealing that off your calculator. What's my label? Kilometers. 1,000 times 1. 1,000 hours. Are we in the units they wanted? Now what's the last step I should do? Divide this. Actually, don't even use your calculator. Why? Your zeros cancel, yes? So really it's 162 kilometers per hour. And then it says, how many kilometers will it travel in 5 hours? What do? Take 162 times 5, 810 kilometers. Do we need to do another one of these? I'm thinking we should. I'm thinking we should. Okay? Grab a piece of paper. If you have it, that's fine. Stop. It's okay to struggle. It's fine. But he's not the one to help you. Who should help you? Me. So zip it. Grab a piece of paper. Okay. Let's do something simple here. Let's go 5,400 inches to miles. 5,400 inches, and we're going to convert it to miles. What did you start with? 5,400 inches over 1. Okay. I need to cancel inches, so where's it going to go? In the bottom. What am I going to change it to? I was going to say, I don't know about you, but I don't know how many inches are in a mile, right? But I know how many inches are in a foot. How many inches are in a foot? 12 inches in 1 foot. So then inches and inches cancel. Multiply across. What do you end up with? 5,400 feet over 12. Just 12. Just 12. Your inches canceled. Okay. Now I need to convert feet. So it's got to go on the bottom. And it's going to convert to miles. Here's the real question. How many feet are in a mile? 5,280, right? Now you guys make me question myself. You should know that. Yes, you should know how to convert that. That's a lie. That's a lie. If I called your intermediate teachers, they would be angry. Yeah. Okay. Feet cancels feet. Multiply across, you get 5,400 miles over like that. And last but not least, you should divide. Take 5,400 miles divided by 63,360. Zero 0.085. Anybody else? Yes? What's my label? Miles. Miles. So that was just one conversion. That was just the inches to miles. Are we good when it's one conversion? Okay. Let's do a 2 conversion one. "36 centimeters per second to miles per hour." One inch equals 2.54 centimeters. You know, 36 centimeters for 1 second. Which one do you want to convert first, centimeters or seconds? Centimeters. Where does it need to go? What do you want to change it to? Inches. Very good. And my connection? 2.54 centimeters for 1 inch. Make sure you put your numbers in the right spot, right, with the right labels. Centimeter and centimeter. Multiply across, you get 36 inches over 2.54 seconds. Let's stick with inches. What are you going to convert inches to? feet. Inches needs to go in the bottom. What's your connection between inches and feet? 12 inches in 1 foot. Inches cancel inches. Multiply across.
Oh, for the bottom.
36 feet over 0.48. And your label? Seconds. Okay, I'm going to rewrite that so that I don't lose it. 36 feet over 30.48 seconds. Okay, what are we going with now? Feet is going to miles. Where's feet got to go? Bottom. What's your connection? 5,280. Feet cancels feet. Multiply, we get 36 miles. Like that. 160,934.4.
Yeah.
And my label. Seconds. Woo! We got one done. Yay! Okay. Now what do we need to cancel? Seconds. Where's it got to go? Top this time. What are we going to convert it to? Minutes. Connection between seconds and minutes. 60 seconds and 1 minute. So seconds canceled seconds. 36 times 60. Say it again. Thank you. And label would be miles, correct? Over 160,934.4 minutes. 2160 miles over 160,934.4 minutes. All right, what are you converting now? Okay. Minutes has got to cancel, so it's going top. What's my connection between minutes and hours? 60 minutes in 1 hour. Minutes cancels minutes. When I multiply, I get like that. Miles over 160,934.4 hours. And last but not least, now that we have everything matched up, we're going to divide to get 0.8. Did you round? Does it fill your whole screen? Does the decimal fill the whole screen? It does? Okay. 81 miles per hour. I was going to tell you not to round, but if it fills the whole screen, then obviously we should round. That's why I asked that question. Maybe we should write down some quick conversions so you remember things, huh? Okay. 1 foot equals how many inches? 12 inches. 1 yard is how many feet? 3 feet. 1 mile is how many feet? 5,280. Write this down. King Henry died unexpectedly drinking chocolate milk. Kilo, hecto, deca. This is your units. Deci, centi, and milli. See if you guys can do this. I want you to tell me the connection between grams, not grams. Let's go liters and milliliters. What is my connection between liters and milliliters?
1,000 milliliters.
1,000 milliliters equals a liter. True or false? So 1 liter is 1,000 milliliters. Okay. There's scratch paper in back. Some of you may want to use regular notebook paper just because of the length. The rest of the hour is yours to work.